Okay guys, I hope this video is going to work, but I just drew out a picture so I could show you what I did and where I went wrong today in tutoring. As you see here, for external respiration, we have the alveoli and the capillary that goes past it. Where I went wrong is I drew a second alveoli over here with the capillary that went past it. And that's where I made my mistake with my initial picture. This way will make much more sense. All the numbers of millimeters of mercury are all the same for the oxygen and CO2, but the drawing itself is just a little bit different. So one thing, if I had read a little more careful, external respiration, this morning I kind of defined it as external respiration, breathing out, and internal respiration, taking a breath in. That's not what it is, and I apologize. External respiration, it's important to know that that occurs at the lungs, hence the alveoli here. The internal respiration occurs at the tissue. So, if our blood is coming in over here, now remember this is used blood, so the numbers make sense that the partial pressure of oxygen is low, let's say 40, and the partial pressure of carbon dioxide is high, because we just picked up all that waste going through the body system, let's say 45. And remember the units are millimeters of mercury. As they pass and go through the lungs, here is just a macro photo of where this capillary bed is going, where it kind of hugs that alveoli, where the air lies in the lungs. As it goes through here, we're obviously going to be picking up oxygen from the lungs and unloading CO2 to then fill the lungs back up for us to breathe out. So our partial pressures of oxygen are going to be increasing, right? Because we're loading it on from the lungs. So as we go through here, our partial pressures of oxygen are going to go up to, let's say, 80 about here, 90 about here, let's say 100 about there. And these are, again, millimeters of mercury. And at the very end, our partial pressure of oxygen is going to be the 104 millimeters mercury. Okay, and that's partial pressure of oxygen. Okay, now as we pass through here with the CO2, we're offloading it into the alveoli. So our number is going to be going down since we're getting rid of some of our carbon dioxide. So let's say where we have the 80 here, let's say we're now at a 43, 42, 41, and then finally we have 40. And that is partial pressure of carbon dioxide, 40 millimeters of mercury. So does that make sense? We come into the lungs, used blood, we go through the lungs and we pick up blood and offload the waste, so we come out with a higher partial pressure of oxygen and a lower partial pressure of carbon dioxide, which is what our numbers reflect. Now that we are leaving the lungs, we're going to go out as oxygenated blood and go to the system to oxygenate all of our tissues. That is where internal respiration occurs, at the tissue level. So these are indeed the numbers that are going to enter and start offloading the oxygen into the cells and picking up the waste that they have been making, waiting for new blood to come through. So we're going to be picking up and onloading the carbon dioxide, and we're going to be offloading the oxygen that we just received from the lung. So our numbers begin high in oxygen, low in carbon dioxide, and as we go through here, we're going to offload the oxygen to nourish our cells, and we're going to pick up the waste. So as we move through here, it makes sense that our oxygen numbers are going to go down. Let's just kind of work backwards. 90, 80, 60, and ultimately, when it's time to go back to the lungs again and we've used and offloaded all of our oxygen, at the end, we're going to be back to 40 millimeters of mercury of the partial pressure of oxygen. Okay, so we just spoke about oxygen. Let's talk about carbon dioxide. What are we going to be doing here at the tissue level? We're going to be picking it up from the tissues. So this number is going to increase. All right, so let's say we go to 42, 43, 44, and finally at the end, our partial pressure of carbon dioxide is going to be 45 millimeters of mercury. Okay, and we can take this, and we've gone through the whole system. This is what our numbers look like now, and this tells us that, oh, it's time to go ahead and go hit the lungs again, which will come over here. Here's our numbers, and we will go and make a pass through the lungs again to get our numbers where they need to be before we enter the system and go to the systemic circulation and to go feed all of our tissues again. So I hope that makes sense. So now let's redefine what I botched this morning. External respiration is not breathing out. It's basically respiration that is external, open to the outside world, hence the lungs, because we bring in, when we inhale or exhale, we're dealing with the outside world, right? With the air that we breathe in and out. That is external respiration. But when we're talking about our tissue breathing, and breathing in oxygen and offloading its CO2 waste, that's occurring at the tissue level. So that is all internal within our body, and therefore it is called internal respiration. I hope that makes sense. I hope this video works and you guys can all see it. Again, I apologize. Thank you guys for being so graceful and gracious with my head cold. So anyways, I'll see you guys later. Bye.